In today's lecture, we are going to discuss about alloys. So this is the second unit of the course, and the first unit we have discussed about chemistry of semiconductors. So in the second unit, we start with the alloys. So first we start with the definition of alloys. Alloys are homogeneous mixture of compounds. They contain at least two elements, which means these compounds are mixed together to make some specific properties improved from the pure metal. So alloys are homogeneous compounds formed by mixing two or more elements. In most of the cases, at least one of the element is a metal. So pure metal, when it is in its pure form, we get many useful properties, but they cannot be taken for direct application, which means when we use pure compounds, the property what we expect can be utilized, but you cannot make it as a good product. Its efficiency will alter, or its nature may differ when it is used for a direct application. So what we do is we add a small impurity to that pure metal so that it will become an alloy, which is in most compact form can be used for many applications. So what we do is we take the pure metal and then we mix with certain other elements so that it will get that improvised property, and it can be used for many purposes. So these elements are melted to a molten state, and then it can be cooled by solidification. Next, we discuss about the purpose of alloying, why we need to make as an alloy to make a product. There are several characters or properties which can be improved by making a metal or any element into a alloy. So we will discuss about few of them so that we will understand better. Purpose of alloying. We discuss about few purpose of alloying. The first what we discuss is to increase the hardness of a metal. So we have certain elements like gold, silver. So these metals are soft in nature, and it cannot be made into a product with their softness. So what we need to make is we need to improve their hardness by adding few other elements. So in this case, gold can be added with copper to improve its hardness, and it can be used for making jewels and coins. In a similar way, silver, which is also a soft metal, can be mixed with few percentage of copper to improve its hardness, and again it can be made into jewels or coins. If you look at other example, for example, if you look at iron, its hardness can be improved by adding certain percentage of carbon. So this is iron metal, and when it is added with few percentage of carbon, its hardness gets improved. If you look at other examples, for example, lead, which we represent as Pb, its hardness is improved when it is mixed with 0.5 percentage of arsenic, and this can be made, this compound, I mean the alloy of these two, can be used as making bullets. So the first thing what we do is, to improve hardness, we can make any element into a alloy by mixing with few other elements, so that the property of hardness is improved. The second thing, it can vary the melting point. So on alloying, an element can vary its melting point. For example, if you take wood's metal, its melting point is 70 degrees centigrade. So at 70 degree, this wood's metal, which is an alloy of bismuth, cadmium, lead and tin. So in this case, it has 4 elements, and these 4 elements are mixed together to form wood's metal, an alloy, and its melting point is 70 degrees centigrade, which is lesser than the melting point of bismuth individually, and melting point of cadmium, melting point of lead and melting point of tin. So these 4 elements have higher melting point when they are in pure state, but when they are mixed to form a alloy, its melting point is decreased to 70 degree centigrade. So this tells that it is easily fusible. The alloy is easily fusible, and this can be done by adding few other elements to a metal. The third point, the purpose of alloying can be done in order to increase the corrosion resistance. This is very important point, because every element, almost most of the elements are very active and they react with the atmospheric gas. So when they react with atmospheric gas, it will form a product which is as a result of corrosion. So if a metal or an element is subject to corrosion, it will lead to the reduction of lifetime of the element or the metal. For example, if you look at iron again, which is Fe, when iron rod or iron, whatever is made of iron, is exposed to atmospheric gas, it will combine with the oxygen present in the atmospheric gas to give FeO or maybe Fe2O3 or some other products. So these are oxidized products of iron, which is formed as a result of corrosion. So as a result, what will happen, this iron metal what we are using, it's keep on oxidized towards oxide. As a result, its quality as well as its strength get decreased, and at some point of time you don't get any iron, everything is vaporized into that atmospheric gas. So what we need to do is, we need to mix this iron with certain elements like chromium and nickel to form an alloy which is called stainless steel. So this is an alloy which can protect the iron from getting oxidized into Fe and Fe2O3. So this stainless steel has a property of corrosion resistance. So when we mix a metal with few other elements, that will improve the corrosion resistance property of that metal. In the fourth point, we are going to discuss about the activity, or in specific I should say chemical activity. Chemical activity of an element. So chemical activity of an element can be varied by alloying. We have, for example, sodium. So this is a very active, very reactive metal. So sodium is very reactive, so it reacts with any other gas or with water vigorously, so that it will cause several damages. So in this case, the reactivity of sodium is reduced by alloying with mercury. Hg is mercury. So on alloying, we will get sodium amalgam. So this sodium amalgam will make the sodium less reactive. So thereby we have reduced the reactivity of sodium. In a similar way, we can also oxidize, we can also make an element like aluminium, which is less reactive, can be made into more reactive by alloying. So by alloying, we can improvise the reactivity of aluminium. So aluminium, when we mix with the same mercury, it will increase its reactivity. So the same amalgam of mercury reduces the reactivity of sodium and it increases the reactivity of aluminium, and both are alloys. This is aluminium amalgam and this is sodium amalgam. The next point is to modify the color. For example, you have aluminium and tin. So their color is silvery white, and if we want to change this color, we can add a little bit of copper. So this will make aluminium bronze. So the color of aluminium bronze is golden color. Thereby we change the color from silvery white to golden color just by adding copper to this mixture of aluminium and tin. So we can modify the color of any element by adding some element to them. The final point what we're going to discuss is castability. Castability is nothing but how easily it can take the structure of a or shape of a mold. So you have an element which is, when it is melted and then you pour that into a mold, how fast or how easily it takes the shape of the mold is called castability. So you have type metal. So this is an alloy. So this alloy, it consists of lead as the main compound, and then to it is added 5% of tin and 2% of antimony. So lead, when it is in pure form, its castability is poor, so it should be mixed with 5% of tin and 2% of antimony to make type metal, which is an alloy of lead, so that you have an alloy whose castability gets better with the addition of these two elements. So here we have discussed about purpose of alloying. There are several purposes you need to make an element into a alloy. First, we discussed about hardness of the metal, which means we can improve the hardness of a metal or an element by adding few other elements. So in this case, we added copper to gold and silver to improvise its hardness, and in the other case we added carbon to iron to make it improvised hardness property. And in the second case, we discussed about the melting point. We can improvise the melting point of any given element by making it as a alloy, so that when we reduce the melting point, it will be easier for any element to make it as a product. Third point is the corrosion resistance. In nature, there are many metals which are very reactive and they will react with atmospheric gas, and it gets easily corroded so that its lifetime is reduced. So in such cases, we need to make them as corrosion resistant material, so that it needs to be mixed with few other elements in order to improvise its corrosion resistance property. And the fourth case, we discussed about the chemical activity of an element. So sodium, whose activity is reduced by mixing it with mercury, making sodium amalgam. And in the other case, the aluminum alloy, which is again an alloy with mercury. So aluminum amalgam is reactivity is improvised on making it as a alloy. In the fifth case, we have discussed about how we can modify the color of a element by mixing it with some other elements. And then finally, we discussed about castability, how we can improvise castability of an element by mixing with few other elements. So in this case, type metal is an alloy of lead whose castability is improvised by mixing it with tin and lead. Next, we will discuss about classification of alloys. How alloys can be classified. So classification is based on iron content of that alloy. So if you are given an alloy, you have to look at the iron content to classify that alloy into two categories. The first category is ferrous alloy, and the second one is non-ferrous alloy. The first case, as the name tells, it is ferrous alloy. So one of the main component should be iron. So one of the main components should be iron, and in this case iron is not main component. So when your alloy contains iron as the main component, it is classified as ferrous alloy, and it doesn't have iron content means, or it contains very few percentage of iron means, it is classified as non-ferrous alloys. Next, we look at the example. So in the ferrous alloy, we can say stainless steel as a example. For example, as we discussed here, iron is the main compound, and for improvising its corrosion property, we added chromium and nickel, so that this is a iron containing alloy. That's why it is classified as ferrous alloy. So it has iron and then chromium and nickel. So one of the main component is iron. That's why it's ferrous alloy. And in the non-ferrous case, we have copper alloys, which does not have any iron content. Likewise, you have aluminum alloys. So these alloys does not contain iron as a main component. That's why these are classified as non-ferrous alloys. You have certain properties which are common in the case of ferrous alloys. So the very important properties are its high yield point, and strength. So these are common properties in ferrous alloys, and they are usually corrosion and abrasion resistance. So corrosion and abrasion resistant compounds, and the other important property is distortion and cracking. So these are less in ferrous alloys, and in the case of non-ferrous alloys, the important properties are usually they are soft and they have a good appearance and high, or we can say multi temperature adaptability, which means they can adapt for different temperature ranges. That's why it's called multi-temperature adaptability. They have low coefficient of friction, and the final property is they too are corrosion resistant materials. So we have classified alloys into two categories. One is ferrous alloy and non-ferrous alloy. So these are classified based on the main component present in them, and if they contain ferrous or iron as the main component, one of the main component, then it is called ferrous alloy. If it does not have, then it is classified as non-ferrous alloy, and it has certain properties in common for ferrous alloys, and you have certain properties in common for non-ferrous alloys. So this is the session for today. So we have discussed about what is an alloy and what is the purpose of making an element into a alloy, and how alloys can be classified into two categories based on the iron content present in the compound what we are looking at. Thank you.